Hello everyone, and welcome back to our second and final video on Chapter 1 for Abstract Algebra. And what we're going to continue with this time is the symmetries of the square. We saw these operations that we did last time in the symmetries of the square. Hopefully we can flip back to those here. Hang on. So you see what we came up with last time. We're going to start from there this time, but I did want to mention a few other things here. So let's start off. We have these symmetries of the square, right? We have these symmetries of the square. We always start with the square in the same formation. If we didn't, things could get us confused pretty quickly. So we start in the same formation, and we either go about these rotations, these counterclockwise rotations of 0, 90, 180, or 270 degrees, or these flips about a vertical axis, a horizontal axis, the main diagonal, which runs from upper left to lower right, or the off diagonal, which runs from lower left to upper right. One thing I do want to point out here is these end results, these 8 end results, don't give us every possible arrangement for those colors on the corner of the square. In fact, we have some outcomes that we never see in this result, and these that I'm putting the dots on right now, these 16 squares are all outcomes we never see. Now, one thing we might ask is, are we missing some sort of weird things we could do to the square that would give us these outcomes? Hang on. There we go. Are we missing some things we could do to the square? And on top of that, how do I know, or do I even know, that these ones that I've gotten over here at the end are all the possible arrangements of those 4 colors around the corners of the square? And that second question, how do I know that all of these original 8 that we came up with over on the left-hand side and these additional 16 that I came up with on the right-hand side, how do I know that those are all of the possible arrangements? And there is a way you can probably answer that, and maybe I'll get back to that toward the end of class. But what I want us to look at now is, instead, what happens if we repeat one of these operations. So, we had this square and we would do something to it. We would either rotate it counterclockwise a certain number of degrees, or we'd flip it about one of its axes, one of its vertical, horizontal, or one of its diagonal axes. There's no reason we have to stop there, though. We can actually continue that process on what we get at the end to see what we get if we do something twice like that. So what I would like for you all to do, first, let's look at these 3 right here, where we have one rotation followed by another rotation. You notice I didn't do every possible set of examples here, but we have a rotation here of 90 degrees, followed by another 90-degree rotation. I'm going to have you pause this video, but you can probably even think through this and figure out what's going to happen. Or a 90 followed by 180, or alternately 180 followed by a 90. So let me get all the stuff back on the screen so you can see it all. And what I would like for you all to do is arrange the corners, what happens after one rotation, then what happens after the next. And when you unpause the video, we'll go over that. Okay, if we're back, let's go ahead and take a look. So here, a 90-degree rotation, we actually can look directly up above and see what that does to our original square, so we don't actually have to go through figuring that out again. It puts the pink down there. It puts the yellow upper left. It puts the green upper right. and it puts the blue in the lower left. Okay. And if we do a 180 degree rotation, that arranges them a little bit differently. We have a blue in the upper right, a green in the upper left, yellow in the lower left, and a red or pink in the lower right. So that is how those happen. We already saw that last time. We don't need to do those again. Oh, and I do need that other blue, don't I? All right. So, what happens if we rotate this again? Well, all we've got to do is go through the rotation. So, let's put the little rotation symbol that I draw in here. So, just to remind ourselves that we're doing a counterclockwise rotation. These aren't as nice as the ones I drew up above. Actually, this video took a long time to set up because of all this stuff. I did eventually find out I can draw squares with the app rather than manually. So the squares are all drawn using this operation up here now, and so they're a lot straighter. The arrows are still drawn by hand, so those might look a little bit crooked. But in any event, we take this. That outcome that we got from our first rotation, and we rotate it counterclockwise 90 more degrees. Well, everything moves around the square one spot. So yellow moves there, red moves over to the lower right, blue moves up, green moves backwards. And if you'll notice, when we're done with this is the same as one of our outcomes above, and it shouldn't really be any surprise to anybody, but this is the same as what we got when we did a 180 degree rotation. Which makes sense. This is a 90 degree rotation followed by another 90 degree rotation. That should be the same as a 180 degree rotation. And because of that, you can probably guess what the other two are going to look like here. If we do a 90 degree and then we do 180 degrees on top of that, we move everything 2 times around. So we get a green dot down here. We get a blue dot right there, a pink dot right there, and a yellow dot right here. And if you notice, if we look up above, you'll notice this is the same as a 270 degree rotation. So we can put that in now. And our next question might be, is the order of this, the order that we do these rotations, going to matter? And just thinking about what you've learned in your math career to this point, you can probably have a pretty good idea of that, even if you hadn't already done it. But what we find out is, no, the order did not matter. And we do a 90 degree rotation starting from the 180. So everything moves one spot around. Yellow moves to the right. Pink moves up. Blue moves back. Green moves down. And again, here we also find this one is the same. As R 270. So that is what we find there. So, and you could probably even do this with all the other possible rotations, figure out what you get if you do them in order. I imagine it wouldn't be very hard for you, but we'll finish that in without actually working through it here in a little bit. But what we'd like to do now is something that may not be quite as obvious. What happens when we do a rotation followed by a flip, or a flip followed by a rotation, or a flip followed by another flip? How do those things work out? Do they work out the same as the rotations did? Is it possible we'll get one of these outcomes we never see up that we saw in the top right here? Or will they still all be ones that we saw originally? Is there going to be anything interesting happening there? We don't know yet, so why don't I have you do these 4 two-step processes right here. I'll leave enough on the screen so that you can see the original versions and how they work, and you can go ahead and pause the video and get back to me when you're ready. Okay, so let's go ahead and fill in these first ones here. The 90-degree rotation, we already saw what that does. It puts yellow up here, pink down there, blue there, green there. And vertical flip, we can look up above. It puts the green there, yellow in the top left, pink in the top right, and blue in the remaining spot. A horizontal flip puts, I guess I don't need to change that yet, blue in the upper left, yellow in the lower right, green in the upper right, and pink in the lower left. And finally, the diagonal puts pink in the, leaves pink in the upper left, and green in the lower right, but it swaps the blue and yellow, so yellow goes to the lower left, blue into the upper right. Okay, so that's what we get in the first step. We had those up above, it's nothing new. But now we want to repeat these processes. So here, let me see if I can use this thing here. Let's try. I haven't done one of these yet. Dotted line. So vertical flip. Should be a flip about. Hang on, if I can get it. There we go. A flip about that line. So let's go ahead and do that. Well, everything gets flipped to the other side, left to right, so blue goes there, pink goes there, green goes there, yellow goes there. So we've done 2 steps, we get this result. Let's look and see if we can find one that matches. Go ahead and see if you can find one of these that this matches. Pause it if you need to. Well, did you find it? I believe you did. It is what we called D prime, the off diagonal flip. So this is the same, sorry, let me try and write this a little bit clearer. Same as D prime. That's what they called me in college, D prime. All right, so that is what we get there. Well, that's not necessarily a surprise. We see we didn't get one of those outcomes we never see, and in the end we'll find out we never get one of those, and I'll explain to you why. But let's try rotation now. 90-degree counterclockwise rotation from where we had flipped it to begin with. So everything moves around the square counterclockwise. So yellow goes there, red goes there, or pink, whatever we call it. Green goes there, blue goes there. Now, we can I haven't looked up above to see what this is, but we can already see it's not the same result we got from doing these in the other order. If we look above, we see instead of D prime, we get D, which is this one right here, right? This one right here. So we don't get D prime anymore, we do get D. So what we're seeing is this thing behaves differently based on what order you do these rotations and flips in. So this is the same as D, not D prime anymore. Okay, now the next one we're going to do H and then a diagonal flip. So we've already got the end results from H. Let's do the diagonal flip. That doesn't, it leaves the things on the main diagonal alone, so the blue stays here, the yellow stays here, but the green and red reverse. So green goes there, pink goes there, and if we look at that and we look up above, we see that that matches, hang on, did I do something wrong? No, I did not. We see that that matches, which one does it match? It matches, surprisingly, maybe, a 270 degree rotation. So you see here, oh yeah, I should have done this, shouldn't I? Hang on, oops, this one. So we did that, okay. That's what we did there. So this turns out to be the same as a rotation. Two flips give us something that ends out being the same as this weird 270 degree, or this 270 degree rotation, which is kind of odd that we can do two flips and find out that we get a rotation. Well, let's try the next one. See if this is also a 270 degree rotation. So here I want a flip about a horizontal line. So in other words, I should flip it about that line right there. And that means everything goes up from the bottom. So yellow goes up there, green goes up here. Oops. Blue goes down here. Oops. I know it doesn't matter, but you know, whatever. There we go. And this is our end result. Now, again, we can already see that this is not the same thing we had directly above. The colors are not in the same place, not in the same places at all. And if we hunt above, well, let's see. Let's first check all those outcomes we never see. No, it's not any of those. What we do see is this is the same as this 90 degree flip that we see up here. Oops. Let me try to get that in the middle. There we go. See up there. So this one is the same as a 90 degree flip. So what we're seeing is the order that we do these things in matters. Okay. Now, so we see we get some interesting results here. Not so much with just rotations followed by other rotations. Those are exactly what we would expect them to be. But when we do a flip followed by a rotation followed by a flip, or two flips, we get things that don't necessarily go in the order we might expect them to, or don't necessarily result in what we might expect them to, and the order on those matters. Before we get into this little chart I've got at the bottom that you're probably wondering about, let's talk about these outcomes we never see and why we never see them. Remember, when we came up with this was an actual physical square, right? This thing we had in the upper left here, this was an actual physical square. I actually asked you to make one of these by hand. The ones that you'll notice over here, the outcomes we never see, you'll notice in the original square, red and green are opposite. There is nothing we can do to wind up with one of these over here where we have red and green adjacent to one another. So you'll notice in all of these that we've got on the other side, red and green are always adjacent to one another, and there's no way you can actually just move a square around. You'd have to cut corners off and tape them together to get those, and that's why we never see these outcomes. These are all things that we just do physically with the square. Flip it over, turn it counterclockwise or whatever. That's all we're doing. So we can't get these outcomes, these extra 16 outcomes. Oh, and why do we have them? Well, you might have already guessed this. We had 8 that we used. and 16 that we didn't use. If we add that up, that's usually 24, which is, anybody know what that is? Maybe you do. It's 4 factorial. Essentially, we have 4 spots. If we start in the upper left and color that one, move around the circle, or move around the square, we have 3 options for the upper left, then, or 4 options for the upper left. Then once we've used one, we only have 3 options for the next spot, then 2 options for the spot after that, and then 1 option remaining. So 4 times 3 times 2 times 1 is why we have 24 total options. Anyway, that's why that is. Well, what we're going to do now is we're going to make a table. This kind of table here is what we call a Cayley table. We'll talk more about that in the next chapter, but that's what this is here. Hang on. And this is for the symmetries of the square, and we're eventually going to have a name for this. Let me go ahead and put it up here. This is what we call D. I'll leave a space there and draw it in myself. D. Hang on, let's. D4. That's what we call this thing that we've got with the rotations and flips of a square. So what we're going to do here is we're going to set this up. You could set this up either way, but when you typically do this, you have to pick what order these are in. What order we have the ones that we're going to put in this column going down the side, and what order we're going to, whether we're doing the ones down the side first or the ones across the top first. So you have, that does have to matter here to you. And I'm going to try and do this the same way the book does it, which is a little bit awkward because the book does make mistakes. So, one thing here you have to be a little bit careful about is what order we write these in. So, let me explain why we're doing this. So, let's put a little note over here. So the ones down the side happen, and I'm going to underline this, second. But are written first. Second as well, but are written first. And you might wonder why we would do something that crazy. Well, the reason is we write these the same way we would write in function notation. You remember, if we have a function and we plug it into another function, the thing that we do first is the inside part, and the thing that we do second is the outside part. Well, that means second is on the left, first is on the right. Hang on, let me make that a little bit better. So second is on the left, first is on the right. So the ones down the side happen second but are written first. I guess I should say not written first here, written on the left. Okay. That's a lot better than what I was writing in. I'll have to adjust those things up above before I save this as a PDF. Okay. So we've got 8 different things here, remember. We've got R0, R90, R180, R270. I'll try and put these in the order the book does. H, V, D, D prime. And I said there's a couple things awkward. First is these aren't necessarily, like I said, the ones on the side are the ones that happen second, but they're written on the left. So that's awkward. Also, the book has a couple of mistakes in that chart, so we've got to fix those as well. 180. Oops, hang on. That ain't right. There we go. 270. And then they do these HV. These are just symbols, like there's no specific ordering that has to be here for these. So, but we've got to do them. Okay, so here, the first part is this upper left-hand corner. You remember here what we saw, and let me rewrite these things here with a thicker line so it'll be easier to read. Let's go ahead and do that real quick. Same as R90. Oops. 180. And then the two below were same as R270. So you'll notice here, when we were doing these rotations, we found that the examples we did, and it's pretty easy to understand why that generalizes to the others, it doesn't matter what order you do those in. Essentially, you're just adding the angles. So what I'd like for you all to do is fill in this upper left-hand 4x4 here, where it's all rotations. Should be pretty easy. Go ahead and pause the video. I'll come back and fill it in with you. Okay, so obviously, if you're back, R0 doesn't change anything, whether we do it first or last. And in fact, we'll be able to help ourselves out a little bit there. Even more when we're done. So R270. And same way down the side. This is R90. R180. R270. But if we do 2 rotations in a row, we find out that they add their angles together. So 90 and 90 is 180. 90 and 180, we saw either way was 270. Oops, what was that? 270, 180 and 180. Well, that's 360, which winds up being the same as R0. 270 plus 90 is the same again as R0, that's 360. 270 plus 180, that's 360 plus another 90 degrees, so R90. This is also R90. This is two 270s together are a full circle and another half circle, which is R180. And this one, what is this? 270 and 90, which is R0. Okay. So that part is easy to fill in. The book didn't make any mistakes there. So, now, the other part that's easy to fill in, R0, remember, doesn't change anything. So, whether you're going across the top or down the side, in the R0 row and column, these things all remain the same. Okay? No changes happen there. Another couple things are easy about it here. If we think about what happens if we do a horizontal flip followed by another horizontal flip, well, that should get us back to where we started. In other words, no end result changes. Same thing should happen with a vertical flip followed by a vertical flip, or either of the diagonal flips followed by themselves. So we should get R0 all the way down there. If we flip something side to side and then flip it back, it goes back to where it started. Now, for the rest of these, we do have to fill them out, and here it can be a little bit tricky. So the ones down the side, remember, happen second, but are written on the left. So here, for instance, if we look at what we did up here, we should see that V R90, hang on, let me write this. If we look at this top one, remember this one, we said was the same as D prime. Remember, that's important because that's my nickname. I'll expect you all to address all emails to D prime from now on. No, that's just a joke. You don't actually have to do that. That would be weird. All right, so here, V R90, this is D prime. On the other hand, we saw R90V was D, right? So these are, come on, man. Let's do this one too. So they're kind of backwards from the way you would think that they would be. So it can get a little bit tricky here. Okay. So V, when it happens second, after R90, that means it's down the left-hand side, and we should have a D prime here. On the other hand, if we do R90 second, we should have a D up here. Okay. So, we see that. Likewise, here, let's erase these. This is the same as R270. And this one down here was the same as R90. Should probably make the eraser bigger, but whatever. Okay, so if we do those down here in the appropriate order. Remember, the second one is written on the left, so here DH equals R270, whereas on the other hand, HD equals R90. I know that looks sloppy, I'll fix it. So D, then H is R270, so we get an R270 here. That's DH. HD, on the other hand, we should get an R90 up here. And let me fix these here. Nope. Okay, that's fine. Hopefully I'm remembering these right. It was just 2 seconds ago, so there we go. All right. DH. Yeah, okay. So we see we can fill these in that way. Now, there's still a lot to go through. We don't know everything about a Cayley table just yet, so it can be tricky. What I would like for you all to do is pause this video and do that, but let me give you a couple of hints beforehand. One thing, if you do a Cayley table, every row and column have to be filled with all 8 symbols. So you never have a symbol repeat in a row or column. It's like a Sudoku in that sense. There's no like squares that are broken up that way, but each row and column, like you never have 2 D's in the same row, or 2 V's or 2 R270s in the same column. So that can save you a little bit of time. So go ahead and try to finish these out. Let me fix this up here. And when you, let me write this out so it's readable when you all get the PDF. Okay, so go ahead and try to finish filling these out. Now, one thing I do want to let you know, the book does have some mistakes, so go ahead and try this, and I'll get back to you here in a second. Alright, it's been exactly 1 second, so let's take a look here. So if we do, I'll just talk through some of these. If we do H followed by a 90-degree turn, then and one thing you might have already guessed, it's not necessarily 100% obvious from what we've got here, but this upper right hand or upper left hand 4x4 in the Cayley table, those are all rotations. Same thing holds true for the lower right hand 4x4. Those are all rotations. And the lower left and upper right are all flips. So that does save us a little bit of time. In other words, a flip followed by a flip gives you a rotation. A rotation followed by a rotation gives you a rotation. But a rotation followed by a flip gives you a rotation followed by a flip gives you a flip. Or a flip followed by a rotation. It's kind of like odd and even numbers there, or multiplying positives and negatives. So let's go ahead and look at this. If we do H followed by a 90-degree turn, well, that means we have upper left is green, lower left is blue, and if we look at that, the only thing we get there is R270, so, oh wait, no, hang on. H followed by, so we get upper left is green, lower left is blue. Sorry, that's D prime. So H followed by a 90-degree rotation is, did I make a mistake here? Yeah, I did. Where did I make the mistake? Oh, in the order I'm writing them. Okay, that's right. Okay, so H followed by a 90-degree rotation is D prime. That's fine. That goes here. Likewise, if we do the 90-degree rotation first and then H, we get a D there. All right. Part of the reason the book gets this wrong is it's easy to swap the order of these. It's important that you keep those in mind. So, and you'll already notice if we're doing a horizontal or vertical flip followed by a rotation, we get we seem to be getting diagonal flips. It's not going to be that completely. If you do 180, you'll get something similar. So let's take a look at H followed by 180. If we do H followed by 180, then blue goes around the opposite place. We can see there we already get back to a V. So H followed by 180, or actually 180 followed by an H. Either one should give us a V. Let me find where this is. 180. Yeah, so V goes right there. And right there. Well, that actually finishes up this because we know we only have flips here and we know they never repeat, so I have to have a D here. I have to have a D prime there. I'm sorry. Make it look a little bit better. There we go. Okay. So those finish up. Now, let's take a look at D followed by a 90-degree turn. That puts blue at the upper left, red at the lower left. The only one that happens there is so D followed by a 90 degrees, so we get blue at the upper left, red at the lower left. The only one that works on is H, so I get an H right here. And then that leaves me a V here. If I do, what's the other one here? 90 degrees followed by D, then I should have yellow still in the upper left, but green in the lower right, so that should be a V down here. And that leaves me an H right here. Let's see. Doing okay. And we just need, I think, one more of these and we'll be done, or we'll be close to done. On the upper left and lower right. So let's do, let's actually 180 degrees followed, if we do V or H followed by 180 degrees, they reverse. So I get, H right there, and H right there. Likewise, if I do that for the D's, they reverse as well. You'll notice they're, everything's opposite on the D's, so if I do 180 degrees after a D or before a D, I get the other D. So D prime and D. Up here I get D prime and D, and that finishes this off. And, well, it finishes it off once we fill in the remaining ones what they have to be. So that has to be a D prime. This one has to be a V. This one has to be an H. And down here, that one has to be a D. That one has to be an H. That one has to be a V. So we're almost done. We just got to do probably one or two more things in the lower right-hand corner. So if I do a horizontal flip followed by a vertical flip, then I'll wind up with green in the upper left, yellow in the lower left. So that's horizontal first followed by vertical. That's the same as R180. Horizontal first followed by vertical. That's R180 right here. And if we do vertical followed by horizontal, we get the exact same thing, so that is also R180. We find pretty quickly that the same thing happens if we do D and D prime, R180, R180. So D followed by D prime flips everything opposite of where it was to start with. And that really means we're pretty much done. I've just got to fill these in. This, we get an R90. Here we get an R270. Here we get, what's left? R90 here. This is probably R270. This one has to be R90, or R270, sorry. The last one has to be R90. And that fills in the chart. Now you'll notice that this isn't the same chart that they have in the book. It's hard to know exactly how they're setting this up in the book, because they do have mistakes on top of everything. So I don't know whether they're trying to do this left to right order or right to left order. We're doing it right to left order essentially, because we're putting them in function notation order. But the book does them. It's kind of hard to tell because they do have so many mistakes in this that it's a little bit confusing what they wind up getting. But one thing you will notice here is, regardless of what order we put these in, these things do not necessarily commute. In other words, H and R90 give us D, R90 and H give us D prime. Likewise, D and V give us R90, V and D give us R270. So order does matter when we are dealing with flips, at least most flips. As we saw, sometimes they still, order doesn't matter, but a lot of times it does. So that is something to notice about this. Now, the reason I wanted to point that out is the general topic that we're going to get into in Chapter 2, which is groups, is essentially this kind of concept, where we have some elements. In this case, our elements are these rotations and flips, and we're doing them, we're combining them, essentially. We're putting them together. So one simple version of that is just adding two numbers. Your elements are numbers, what you do to them is add them. Or your elements are numbers, what you do to them is multiply them. But you can get into some complicated things here, like rotations and flips like we see here. You can get into dealing with matrices. There are a lot of different versions of this, and not all of our normal properties always work. This is an example of a place where our normal commutative property doesn't work. So, note for this commutativity fails. Let's first move you down there. Move you down there, and it attaches. Nice. All right, so commutativity fails for this. And I know it's weird to think about commutativity when you're not doing addition or multiplication, but the main topic of abstract algebra, and we'll see this more in chapter 2, is sort of a generalized idea of what we normally see with addition and multiplication. And in other words, taking elements and combining them in a way to get a new element out. And that's what we're going to be looking at for pretty much all of the rest of the course. And this is just a first introduction to it. Anyway, since there's so many circus colors here, oops, I should draw you a clown, right? All right. Okay. I'll draw a little face here. Big pink nose. Do, and let's see here. Okay, and let's see, what can I do here? Let's give him some orange hair. I know it's weird to use highlighters to do this, but you got to use the medium that you got, right? Okay, and let's do, oops, little blue eyes. And let's see, what do we do up here? Yellow puffball on top. And I'll try and do, I might actually have to do those in different colors. Blue, pink. Might actually fix the one down there below. Let's see, orange. I can fix his mouth now. That's good. It's not 100% perfect, but whatever. not being graded on this, I guess. Let's see, and yellow right here. Let's make it back to, what was it, 9.5? Okay. And then down here, there we go. I think that looks pretty good. And I guess here, Happy International Clown Day. It's not actually International Clown Day, but whatever. Oh, I know what I'll call it. Clowning Around Day. That sounds good. So that is August 30th from now on, I guess. So there you go. There's your clown. There's your video. And I will be uploading this shortly. Everybody have a good one. Bye.